Hello everyone and welcome back to a new lecture about database. Today we are going to learn SQL subqueries. This lecture provides an in-depth exploration of SQL subqueries. Subqueries, also known as nested queries, are some select statements embedded within another SQL query. And the goal here is to retrieve data used by the outer query. So we will cover single row and multi-row subqueries, correlated subqueries, and their application in select, where, and from clauses, and also with several examples. And like the previous lectures, we use our university database with several tables like classroom, department, course, instructor, section, teach, student, takes, advisor, time slot, and prerequisite tables. Okay, let's move to the full screen. So for this one, you just press Alt, Shift, and Enter. So in our database, we have several tables. So let's see our tables from information, schema, tables. So here you can see a list of our tables. In the previous lectures, I show you how to create these tables and add information to these tables. Now we are going to learn subqueries based on these tables with these 11 tables. First, what are subqueries? A subquery, also known as nested query, is a select statement nested inside another SQL statement, or you can say the outer query enclosed in some parentheses. These subqueries retrieve data that the outer query used for filtering, computation, or joining. Subqueries can appear in select, where, from, and having clauses. The first one is a single row subquery. Single row subqueries return one row and one column. We use them with comparison operator like equal to, greater than, less than, etc. due to their single value output. So, for example, I want to show each course's title and the maximum instructor salary in a university, right? So select title. Then, so this is the outer query. Now I'm going to write another query inside this query, right? So select max salary from instructor, and I will call this one as max university salary. From where? From course, right? So let's see. So there should be one comma here. Okay, so you can see here, this is one query, inner query. It finds the maximum salary from instructor, right? The maximum salary from the instructor. Then I will go here and find title, and the output of this one is the one new column here. You can see here max university salary. So all the same here. So this is the maximum university salary for. So this query just shows the course's title and the maximum instructor salary university-wide, right? It's not that much meaningful just to show the subquery of single row. So the subquery, this select max salary from instructor, returns the highest salary among all instructors. This single value that you can see here is under max university salary for each course in the outer. The subquery executes once and its result is reused for all rows, right? Not that much logical, just to demonstrate subquery. The next example is, I want to show each department's name and the total number of courses offered university-wide, right? Again, select depth name, then here from department. Now in here, I will go for one subquery. And in here, I write, I want to find the total number of courses, right? So select count all. I will count all rows from the course table, and I will rename it as total courses. Total courses. So let's run this one. Okay, you can see here, the subquery, this select count star from course, counts all courses in the course table and return only one value, 58. This count is displayed as total courses alongside each department name. The subquery is executed once for the entire query. Now we're gonna see single row in where clause. So I want to find departments with budget greater than the average budget of all departments, right? So for this one, for example, I want to get the name and budget from department where budget. Now the question says find a department with budget greater than the average. So I need to find out the average, then find those departments budget more than average, right? So here I'm gonna write a subquery to calculate the average. So select average of budgets from department. So let's run this one. Okay, this one is the answer. So this select average budget from department computes the average budget across all departments, and the outer query selects department where budget exceeds the average. The subquery returns a single value for comparison. I'm gonna find instructors with a salary higher than the minimum salary in the physics department, right? So again, here I have to write a subquery to find the lowest salary in the physics departments. Then the outer query retrieves instructors whose salary is greater than the minimum one, right? So first I will write the subquery to find the lowest salary in the physics department. Select minimum of salary from instructor. So let's bring this one here. From instructor where depth name is equal to physics. All right, this subquery finds the lowest salary in physics department. Now this one should be a subquery for select name and salary from instructor where salary greater than the value returned by this one, right? So let's run this one. Okay, you can see here, Einstein has a salary higher than the minimum salary in the physics department. So these were single row subqueries. Now I'm gonna write multi-row subqueries. Multi-row subqueries return multiple rows, usually one column, and they are used with operations like in, any, or all in order to handle multiple values. We will use in. In matches a value against any value in the subquery results. Any compares a value to any subquery result, and all compares a value to all subquery results. Okay, here I want to find instructors who teach courses in computer science department, right? So find the name. So okay, select name from instructor where instructor ID is in, then subquery, right? I should go for teach, right? So select instructor ID from teach where course ID is in. Again, I need to go for another subquery here, and I select course ID from course where department name is equal to comp science. Okay, so let's try this one. So these are professors who teach in computer science. This is the innermost subquery. This select course ID from course where department is computer science gets all course IDs from computer science department. Then this middle subquery finds instructor ID teaching those courses via teachers, and the outer query here retrieves name of instructors whose instructor ID is in these results. This in operator here handles multiple rows from the subquery. I want to find a student who took courses with more than 3 credits, right? So in here, again, I need to go for 3 subqueries, right? So one, I need to check whether credit is more than 3 in course. Then I should go to the text and find the student ID who takes this course. Then I should go to a student and select the name, right? So I will go from the most inner one. So the most inner one is select course ID from course where credits is greater than 3, right? So this is 1, right? So this will check credit more than 3. Next, I need to write another query here to find student ID. So select student ID, student ID from text where course ID is in this subquery, right? This subquery here. Then the most outer one, I want to go select name from student where student ID is in this subquery. All right, that's all. So here we go. So once again, the subquery select course ID from course where credit is greater than 3. This identifies courses with more than 3 credits. Then this subquery finds student ID enrolled in those courses via text table, and the other one selects name of a student whose student ID is in these results. This in operator manages the multi-row output. So here, let's try one all operator. First, I'm gonna write a subquery that returns salaries of history department professor, right? Select salary from instructor where depth name is equal to history, right? 60,000 and 62,000. Now, I want to find professors whose salaries are more than professors in history departments. Find instructors with a salary greater than all professors in history department, right? Select name and salary from instructor where salary is greater than all professors in history department. Here we go. And you can see these are all more than 62,000. I'm gonna try multi-row subqueries in from clause. I want to calculate the average capacity of classroom used by physics department courses in 2023. So first, I'm gonna write one query to get physics course ID. So here, I want to find the average. So select average capacity as average classroom capacity, right? This is our ultimate goal. So from I go to the classroom and I will select capacity distinct. I don't need to have repetition. So distinct classroom dot capacity, right? From section. Then here I need to join section with classroom, right? So let's see what do we have in classroom. Select all from classroom. Here we go. So I will join this one section. I will join with classroom. With classroom based on what? We have building, and also, so let's see the section. Select all from section. So we have building and room number, right? So on section dot building is equal to classroom dot building, and section dot room number is equal to classroom dot room number, right? Now I need to make one condition where, so based on this join, I want to get section dot course ID, and this section course ID should come from physics departments, right? So I need to make a query for physics department. Select course ID from course where depth name is equal to physics. Another condition is there that it says in the physics department and semester should be fall and year should be semester. So and section dot semester should be equal to fall, and section dot year should be equal to 2023, right? So then we rename this one as, for example, physics classroom, right? So let's run this one. So there seems we have no data for this query. Let's change this one to AI studies. AI studies. Okay, you can see here AD. This query gets AI studies course ID. Then, so this from section joins section and classroom to select distinct capacity values for classroom used by AI studies in fall 2023. Then the outer query computes the average capacity, right? This subquery, this one that we have named it as a physics classroom, this act as a temporary table. Later, when we extract our knowledge, then it will be deleted, right? So this is how we can use subqueries in from class. I want to find the total credits of courses taught by each instructor in like spring 2024. So in here, I need to join teach and course to select distinct instructor ID and credits for courses taught in spring 2024. So select distinct, and in here, I will rename teach as T, right? So T dot instructor ID, and also I will join this one with course because information are there, and I will name it as C. So I will get instructor ID from teach and credits from course table, right? So I join these two tables on. So let's see what common attribute they have. Select all from teach. This is one, and another one is select all from course. Okay, let's run these two together. So you can see here, we have course ID is common. Okay, so on T dot course ID is equal to C dot course ID, right? Then the question says spring 2004. So there T dot semester is equal to spring, and T dot year is equal to 2024, right? So let's call this one as instructor underscore courses. This is one subquery. Now, in here, distinct avoids duplicate credit if an instructor teaches multiple sections of the same course. Now, we want to go for the outer query to sum credits per instructor ID, right? Select instructor ID, sum of credits, and we name this one as total credits, okay, from all these subquery, right? And also here we can group by them based on the instructor ID, right? So let's run this one. You can see here, this is total credits of courses taught by each instructor in spring 2024. The next topic here is correlated subqueries. Correlated subqueries reference columns from the outer query, executing repeatedly for each outer query row. These correlated subqueries are often used with exist or comparison operators. For example, I want to find students taking at least one course in their own department, right? So I need to write a subquery to check if there exists take record where student ID in the student is equal to teach. This is for enrolled in course from their department, where department name in the course is department name of student. So let's do it. So the subquery select one. So in here, just we write select one. This is a query that returns the literal value one for each row that satisfies the condition of the query. So we normally use this one in subqueries, particularly with exist clause, to check for the existence of rows without needing to retrieve actual data from the table, right? So from text, and we rename this one as T, right? Then we join this text table with course and we name it as C. And in here, in course, so select from text and course. So let's consider this one text. So in text and course, we have course ID common, right? So on T dot course ID is equal to C dot course ID, right? Then where we need to check the student ID as well, right? So we rename here in the outer one, so from student as S, and in here where T dot student ID is equal to S dot student ID. student ID, and also C dot department name should be equal to S dot department name, right? So from students, what do we need? Select student ID and name, and this will be the condition where exist from this subquery. Okay, I will explain again here. So the outer subquery here select student ID and name from the student table. The subquery here check if there exists a text record where the student like T student ID is equal to S student ID is enrolled in a course from their department, right? It means C dot department name is equal to T dot department name. And this exists returned true if the subquery finds at least one row. So this subquery is correlated with S.student ID and S.department name. The next example, I want to find instructors who teach in a classroom with capacity greater than 50. Again, the same here. Name of professor. So select name from instructor and where exists. Okay. Again, select one from teach as T, and we join this table with section as S on again T dot course ID is equal to S dot course ID, and T dot section ID is equal to S dot section ID, and T dot semester is equal to S dot semester. And also S dot year is equal to T dot year. Now, also, we join this one with classroom and we rename classroom as C on. So we have here building and room number, right? So on S dot building is equal to C dot building, and S dot room number is equal to C dot room number, right? Where T dot instructor ID is equal to, we need to rename this one as I, then here we can say I dot instructor ID. And also capacity should be greater than 50. So let's see. Okay, here we go. The outer queries select name from instructors. Then this subquery verifies if instructor like T dot instructor ID is equal to I dot instructor ID teach a section in a classroom where capacity is more than 50, right? Then this exists ensures that instructor is included if at least one such section exists. So this subquery reference I dot instructor ID from the outer query. The subquery references I dot instructor ID from the outer query. For each course, display the number of students in each section in fall 2023, right? Course ID and title from course, and we rename it as C. But in here, we need to write a subquery. Select count from text as T, then where T dot course ID is equal to C dot course ID, and also T dot semester is equal to fall, and T dot year is equal to 2023. So we rename this one as enrollment count, right? So let's run this one. And here we go. This is the number of students enrolled in each section in fall 2003. See, these outer queries select course ID and title from the course table. The subquery here counts enrollments in text table for the current course, like T.course ID is equal to C.course ID in fall 2023. The subquery runs for each course referencing C.course ID, right? And the result appears as enrollment count that you can see it here. One more example here. For each department, show the number of instructors with above average salaries, right? So we need to use a correlated subquery to count instructors in the current department with salaries about the university-wide average, right? So here, select Depth name. So the question says each department, right? Depth name from department, and we rename it as D. Then in here, we go for subquery. So select count from instructor, and we rename it as I, then where I dot department name is equal to D dot department name, and I dot salary is greater than here in this subquery. In this subquery, I'm going to calculate the average salary of professor, right? Select AVG of salary from instructor, right? From instructor, then I will call this one as, for example, as high salary instructors, right? So let's run this one. There must be a comma here. So here we go. This is the number of instructors with above average salaries. So the outer query here, select department name from department table. Then this correlated subquery counts professors in their current department. As you can see here, I dot department is equal to D dot department with salaries above that, the average that we have calculated here. So the subquery references D dot department name and runs for each department. And we rename this one as high salary instructors, this column. Okay, that's all for today. Today we studied subqueries in SQL. Subqueries enable complex SQL queries by breaking them into manageable parts. Single-row subqueries provide scalar values, and multi-row subqueries handle lists within any or all, and correlated subqueries offer row-by-row logic with exists. We can use subqueries in select, where, and from, and in this way, we can solve problems like finding high-budget departments, counting enrollments, or identifying instructors in large classroom. Please practice them with examples and experiment different ways. And please feel free to ask me your questions by leaving a comment below this video. Thank you and see you in the next lecture.